All right, guys. We're gonna start off with a new chapter. It's gonna be 13.1 or 13-1 trigonometric identities. This is gonna be a short chapter. It's only gonna be 2 sections long. Um, so it says students will be able to use trigonometric identities to find trigonometric values and simplify expressions. And your homework is page 876, numbers 9 through 12, 43. Okay. It's just gonna be a lot of just notes, and then we'll do some problems at the end. So the first part that I want you guys to copy is this thing called the quotient identity. I'll zoom in just to make this a little bit bigger for you. We don't necessarily worry about these bottom parts. Just understand cotangent theta, tangent theta is equal to sine over cosine, and cosine over sine, respectively. Okay. All right, I'm just going to move on. Feel free to pause if you need more time to copy stuff down. Like, that's cool. The next part that we're going to talk about is this thing called the reciprocal identities. Once again, ignore these parts. They're just saying sine cannot equal 0 just because the bottom, you don't want to equal 0, okay? And like I forgot I mentioned this, but let's make sure that we have questions and reflections for this section as well, okay? So let's make sure we copy that. Sine is 1 over cosecant, cosine is 1 over secant, tangent is 1 over cotangent. So it's the reciprocal, right? It's the flippage of kind of everything that we've done. This shouldn't be too crazy, to be honest. We've done a lot of this already. Just in terms of like, sine goes with cosecant. We usually flip it. Right, so you guys have done plenty of that. So I'm just going to move on. Next thing that we're going to do is this Pythagorean identities. Okay, so it's these 3 right here. And like I said, most of this stuff is you guys have to memorize it. There's no other real shortcut for it. It's just memorizing. I could go through the process of teaching you guys how to establish this, but for right now, let's just focus on memorizing it. Okay, so make sure we copy that and highlight that. And highlight all these identities. Identities is just a fancy way of saying properties. Okay, they're properties. They're statements that are true. Okay. Now, manipulating it, what I mean by that is, let's say I have cosine squared theta plus sine squared theta is equal to 1. Like, we should definitely memorize that. But what I mean by manipulating is the idea that you can move stuff around. For instance, I can subtract cosine squared theta to both sides if I really wanted to. And the result would be sine squared theta is equal to 1 minus cosine squared theta. Okay, you can move stuff around. It doesn't really matter what. Like, if I wanted to, I can also move the sign around. So I get cosine squared theta is equal to 1 minus sine squared theta. Okay, and the rest is true for every other one as well. If I have tangent squared theta plus 1 is equal to secant squared theta, you can move the 1 if you want it. This becomes tangent squared theta is equal to secant squared theta minus 1, right? Just for example, that's the idea of moving things around like that. Okay. I gotta stop opening that. The idea that you can manipulate and move things around is just as important as memorizing these top 3. Okay. Now, if I have cosine squared theta plus sine squared theta, right? I might as well just show you where this is coming from. If we look at our unit circle, right? If I'm talking about a unit circle, the radius will always be 1, right? Because if it's a circle, the radius is 1. That's the definition of a unit circle. If I drop this down, this is x and this is y. So in reality, I have x squared plus y squared is equal to 1, right? That's your Pythagorean theorem or Pythagorean identity, right? And once again, the radius is 1 because it's a unit circle. A unit circle is a circle with radius of 1. So using Pythagorean, I get x squared plus y squared is equal to 1. But if you guys remember from the unit circle, I actually told you guys that cosine theta is equal to x, right? And sine theta we refer to as the y coordinate. So all I'm doing is I'm making a substitution into for x and y. So instead of x, I'm writing cosine. And because it's squared, I'm squaring it. Instead of y, I'm writing sine. And it says y squared, so it's sine squared theta is equal to 1. Okay. Now, the way that I get the other two identities, for those that are curious, because this is going to come up later on in your future math classes, is if I divide every single thing by, let's say, sine squared theta, right? And I can do that because I'm doing it to every single thing. So if I divide sine squared theta everything, you get cosine squared over sine squared. If you guys remember from your quotient identity, cosine over sine is cotangent. So this becomes cotangent, but because they're both squares, it's cotangent squared theta plus sine squared over sine squared is 1 is equal to 1 over sine squared, okay? 1 over sine is right here, and that's cosecant. So it's cosecant squared theta, and that's how I got this one right here. Now I can do very similar thing. If I start off with cosine squared theta plus sine squared theta is equal to 1. If I decide to divide everything, instead of just dividing by sine squared, divide everything by cosine squared, cosine squared over cosine squared is 1 plus sine squared over cosine squared is tangent squared is equal to 1 over cosine squared, which is secant squared. Right? And that's just me using the quotient identity and the reciprocal identities, right? Just like how I did over here, but now I have different identities. So that's how you get the other two. Like, you have to for sure memorize this first one, and you can get the other two by applying your identity rules. All right, next slide. The cofunction identities, let's just copy this. This is not the most important identity, like, at all. It's good for you to know, but God, I gotta stop opening my AirPods. It's good for you to know, but it's not make or break like the other three that I've shown you already. These are okay. So I'm gonna move on. These are useful. They kind of help out. They make your life a little bit easier if you know how to use them. So I would copy them. I would definitely copy them, and just to see what you can do with that. And as the time comes on, I'm gonna help you guys memorize it, or I'm gonna teach you guys how to apply it. That is, okay. Notice the negative for here can come out. Cosine, the negative, just goes away. The negative for tangent comes out. Okay, these are also called what are called the odd even identities. I can do something similar if I have secant negative theta. If you remember, secant goes with cosine, right? Secant and cosine kind of line up together. So it follows the same rule as cosine, so that just goes away. Right, and so on. So I'm just going to move on from there. So you can apply your reciprocal identities to these as well. Okay, let's actually see these in action. Okay, I have sine, but I want to figure out cosine. You see this right here? This tells you that you're in quadrant 2, right? If I have sine, I want to find cosine. Quite simply, you want to find an identity that ties cosine and sine together, and the identity that does that is the cosine squared theta plus sine squared theta is equal to 1. So I'm making my substitution. So cosine squared theta plus, I know sine is 1/4, so that's 1/4 squared is equal to 1 because sine is squared, so it's squared. Cosine squared theta plus 1 over 16 is equal to 1. I want to subtract 1 over 16 of both sides. So I get cosine squared theta is equal to 1 minus 1 over 16. That's 16 over 16 minus 1 over 16. So that's 15 over 16. Now what I want to do from here is I want to square root both sides. So I'm square rooting top and bottom. So I get cosine theta is equal to plus minus radical 15 over 4. Okay, plus or minus radical 15 over 4. I got 4 because square root of 16 is 4. I'm writing plus or minus because if you guys remember, if we square root anything, we have to include a plus minus. Now, you're only going to have one answer. You see, it's quadrant 2, correct? Right? I know it's because it's 90 to 180, so it's in quadrant 2. If you guys remember this thing, remember I taught you all students take calculus. Here, everything is positive in the first quadrant. So in quadrant 1, everything is positive. In quadrant 2, only S is sine. Sine is positive. If you remember, sine also goes with cosecant, so cosecant is positive, but we remember it as S goes with sine, and sine leads to cosecant. Quadrant 3, only tangent is positive. Right? Remember, tangent goes with cotangent, so that applies to cotangent. And then quadrant 4, only cosine is positive. And like I said, cosine goes with secant, so those apply. That means in quadrant 4, if cosine is positive, that means sine is negative. That means tangent is negative, right? That means tan is neg and sine is neg, right? Same thing here. If tangent is positive, that means sine and cosine are negative. And same thing here. If sine is positive, that means cosine and secant are negative. So looking at here, if I'm in quadrant 2 is S for sine. That means cosine should be negative. So my answer is cosine theta is equal to negative radical 15 over 4. And that's my final answer. Because it's in quadrant 2. And we know that sine is positive in quadrant 2, which makes cosine negative. Okay, here I have cosecant versus cotangent. So I'm going to look which one of these theorems has both cosecant and cotangent. Well, it's the Pythagorean. Knowing my Pythagorean, I know it's cosecant squared theta plus cotangent squared theta is equal to 1. I know, oh no, that's totally wrong. Sorry, it's actually going to be cotangent squared theta plus 1 is equal to cosecant squared theta. Sorry about that. I know I'm in quadrant 4 here. So I'm making my substitution. So I have negative 3/5 squared plus 1 is equal to cosecant squared theta. So I get 9 over 25 plus 1 is equal to cosecant squared theta. So I'm doing 9 over 25 plus 1. 1 is really 25 over 25. So I get 34 over 25. So I get cosecant squared theta is equal to 34 over 25. I want to square root both sides. So I get cosecant theta is equal to square root of 34 over 5 plus or minus. Now you have to figure out, should I be a positive or a negative, right? Well, if I'm in quadrant 4, I know in quadrant 4 cosine is positive, right? Because cosecant goes with sine. So sine is positive in quadrant 2, but we're in quadrant 4. That means that cosecant should be a negative. And that's my final answer there. It's a negative because I'm in quadrant 4, right? Because I'm in quadrant 4. All right. I think I'm only going to do 1A is just like the problem that we did in the other slide. To do 1A, you're doing sine squared theta plus cosine squared theta is equal to 1. And then you're making your substitution. So sine squared theta is equal to, plus 1/3 squared is equal to 1. So sine squared theta is equal to 1 minus 1/9. That's what 1/3 is, and then I just subtract. I don't really like you can do that on your own, and we're in quadrant 4 again, so you just have to understand what that means, okay? What I really want to do is I want to focus on 1b. 1b is a little bit more interesting of a problem because it's secant versus sine, right? It's secant versus sine. So I'm thinking of a way of tying in secant and sine. Obviously here, this is in quadrant 3. Secant versus sine, right? Now, because we have secant, secant's kind of hard to deal with. If we remember secant as 1 over cosine, in my mind, I'm really technically doing sine versus cosine. So I'm doing cosine squared theta plus sine squared theta is equal to 1. So I'm making my substitution there, right? Because secant is 1 over cosine, so I'm using that cosine there instead of just secant. I'm using cosine. Because there's nothing with secant and sine, like in any of our theorems, there's nothing with secant sine. So it's easier to convert secant into cosine. Okay, so if I do that, I get cosine squared theta plus 4 over 49 is equal to 1. Cosine squared theta is equal to 1 minus 4 over 49. Cosine squared theta is equal to 45 over 49, because 1 is really 49 over 49, right? 1 is 49 over 49. So that's how I can do that. I'm going to square root both sides. So I get cosine theta is equal to radical 45 over 7 plus or minus. Now 45 is something dope. 45 you can break down. That's 5, 9. That's 3 and 3. So that's really plus or minus 3 rad 5 over 7, right? I'm making my factor chain. Now you have to decide whether it's a positive or a negative. It's in quadrant 3, right? It's in quadrant 3. Actually, yeah, it's in quadrant 3, right? Because I'm in quadrant 3 is tangent is positive, so it means cosine is negative. So I get cosine is equal to negative 3 rad 5 over 7. Now, if you guys remember, in my original problem, I'm looking for secant, right? I'm looking for secant, not cosine. So to convert back, I don't want cosine, I want secant. The rule is just to flip it, right? I don't like a radical 5 on the bottom, so I'm going to multiply rad 5 top and bottom. So I get secant theta is equal to negative 7 rad 5 over rad 5 times rad 5 is 5, so 5 times 3 is 15, and that will be my final answer. Okay, this one just takes another step just because you have to convert back into a secant. Okay, next problem. The next 4 problems are a little bit more interesting. They are simplifying. I really, really, really like simplifying. Okay, your number 1 rule is convert everything to sine and cosine. Okay, that's kind of your best bet. That is the rule of the day. Convert everything to sine and cosine when in doubt. So that's what I'm going to do. Sine is already sine. Cosecant, if you look up, cosecant is 1 over sine. Right? That's your reciprocal. Cosecant is 1 over sine over cotangent is cosine over sine. Now I'm just going to simplify. Right? These are your reciprocal identities, your quotient identities from like the first couple slides. Sine on top and bottom cancels out, so I have 1, like these cancel out. Then I have cosine over sine. Remember, to get rid of that, you're really doing 1 times the reciprocal of the bottom, right? You're just flipping the bottom, so I get cosine over cosine, which if you look up is tangent. And that's my final answer. My final answer is tangent. Right? I think doing this stuff is really fun, but the rule is to convert everything to sine cosine. Okay, next slide. This is a little bit more interesting. I'm going to convert everything to sine cosine again. So I'm going to get sine squared theta over cosine squared theta. That's what tangent is, right? Tangent is sine squared over cosine squared, right? This is sine over cosine. Cosecant is 1 over sine squared minus 1 over 1 over secant squared, right? Secant squared is 1 over cosine squared. That's fine. And let's see what happens. Sine squares cancel out, right? Like here, this sine squared and this sine squares cancel out. So then I get 1 over cosine squared minus 1 over 1 over cosine squared. There's a couple ways that you can do this. There's a couple ways that you can kind of approach this problem. There's a lot of different steps that you can take. I think what I would probably do is from here, you see this 1 here? I would convert 1 to cosine squared over cosine squared. The reason why I would do that is because if you look at the top is like a complex fraction. Like it's a fraction within a fraction, right? Overall, what you want to do is you want to get a common denominator. By getting a common denominator, you're able to subtract it. So 1 can be whatever you want as long as it's the same top and bottom, right? Like cosine squared over cosine squared is technically 1. What that allows me to do is that allows me to rewrite the top as 1 fraction. Now, if you think about it, you're dividing fractions. If you're dividing fractions, you're really multiplying by the reciprocal of the bottom. So if the bottom is 1 over cosine squared, that's just cosine squared over 1, right? You're just flipping the bottom. Cosine squares cancel out, so you get 1 minus cosine squared. And this looks really familiar. 1 minus cosine squared, right? If you look back here, we got 1 minus cosine squared. 1 minus cosine squared is really sine squared. And that'll be your final answer. The trick to this problem is anytime you see a square and you see a 1, anytime you see a square and a 1 or a 1, you automatically are going to think about your Pythagorean identity. Anytime in the problem you see a 1 or a square, you're going to go to the Pythagorean identity. 1 or square goes Pythagorean identity. So I'm automatically looking back there. I'm trying to see, okay, 1 minus cosine squared. Okay, this looks like it's sine squared. That's my rationale, right? I'm going back there. Okay, let's check out this problem. Now, there's a lot of ways that you can approach this problem. Secant is 1 over cosine, right? Over sine. Now this, once again, do you see? I see a 1 and I see a square. That tells me that that's sine squared, right? I'm thinking about Pythagorean. I get sine squared. From here, you have a sine on the bottom and you have a sine squared on top. They kind of cancel out. So you have 1 over cosine. And what you have left is just a sine on top, right? Think about it as 1 over, let's say, x times x squared. Your answer would just be x because things would cancel out. So now I get sine over cosine, which is equal to tangent. Because that's Pythagorean, right? I just know my identities. All right, last one. I want to rewrite everything in terms of sine. Okay, so this is a little bit trickier. So kind of my go-to move again. Okay, kind of my go-to move is convert everything to sine and cosine, right? So let's do that. So cotangent squared is cosine squared over sine squared. minus tangent is sine squared over cosine squared. Okay, I want to subtract them, so I need probably a LCD of sorts. Actually, I don't. What I can do instead is this. Cosine squared. There's a rule for cosine squared. Would that be the best route? I don't know. There's a lot of ways you can do this. This is why this stuff is like really interesting, because there's a lot of different answers that you can do. And you can have, as long as you're doing it mathematically correct. Let's do it this way. This way is a little bit more straightforward. I see fractions. So if I see fractions, I want to get an LCD, right? The LCD, I believe, would be sine squared times cosine squared. You just essentially take everything in the bottom. So this is missing a cosine squared, so I'm going to multiply cosine squared top and bottom. This is missing a sine squared, so I'm going to multiply sine squared top and bottom. Yeah, let's see that. So on top, cosine squared times cosine squared is cosine to the fourth. Minus sine to the fourth. Over cosine squared sine squared theta. Okay, this is where it gets really, really, really tricky. You really need to know kind of everything that we did this year. You kind of have to apply it to this problem. For example, we know that a squared minus b squared, right, is equal to a minus b times a plus b, correct? We know that. That's not an issue. Yeah, that's not an issue. But we could take it to the next level. I can do a to the fourth minus b to the fourth. That's equal to a squared plus b squared. A squared minus b squared. Right? I could take it to that level if I want. So that's what I'm going to apply to this problem. I kind of have that a to the fourth minus b to the fourth, right? So what I get is, what I'm going to get from there is a is cosine squared, so cosine squared theta plus sine squared theta times cosine squared theta minus sine squared theta over cosine squared theta sine squared theta now from here. Do you see how cosine squared plus sine squared? We should know what that is. That's actually 1, right? So we get 1 times cosine squared theta minus sine squared theta. Oh no. Oh no. Oh no. Oh no. Okay, sorry. Freaking out. Over cosine squared theta, sine squared theta. Okay, I'm going to need a lot more room. This is the trick to get room on this app. You just press enter a lot. You go back in, you extend, and then you're not, and then you can now, you have more room. So what I'm going to do now is, remember, the problem is I only want sine, right? I only want sine. So there has to be a way for me to get rid of cosine. Well, it's cosine squared theta, right? It's cosine squared. If that's cosine squared, we should know how to get rid of cosine squared. Cosine squared is 1 minus sine squared. So in reality, I have 1 minus sine squared minus sine squared over, once again, cosine squared. That's 1 minus sine squared times sine squared And from here, all I want to do is I want to simplify. So my final answer is going to be 1 minus 2 sine squared, right? Think of this as negative x minus x. That's negative 2x, right? Like you can combine like normal over. Here I would distribute, so I get sine squared theta minus sine to the 4th theta. God, that's so ugly. Boom, and that's it. That would be your final answer. All right. Do we have... Yeah, I was going to say, do we have any questions? But you guys are not in front of me. That's awkward. All right. Anyways, that's about it. I know this last problem is really hard. I get that. Hopefully, you can kind of understand step by step what we did with it. Okay. Now, this is what we're going to do because I want to make sure that you guys are all watching these videos. So now that we're at the end of this video, if you guys go to the Google Classroom and under this post, if you comment a compliment about me, yeah, let's do that. If you guys compliment me in the Google Classroom comment to prove that you guys have seen this video, I'll give you guys extra credit. Okay, so go ahead and do that at the end of this video. Comment inside the Google Classroom thing. Okay. Besides that, we'll probably do an office hour thing on Monday, for those that have questions. For those that have questions on the assignment. Okay. So yeah, that'd be that's pretty much it. Have a good weekend. Try your best with this. We're gonna spend a little bit of time on chapter 13 just because chapter 13 is kind of gnarly. Okay. All right.